So we learned about y equals mx plus b slope-intercept form in the last lesson. And it turns out using that is the faster way to plot a linear function. The way we learned in 3.2 was the slow way. Both ways work, and we're going to see that today. Okay, so we're going to draw ramps for each of these slopes. So for 1/3, if you make that 3, then 1, you first of all should be straight up and should be about 1/3 as long as the run, right? So our rise here is 1 and our run here is 3, right? And they're right triangles. They're not like this. Okay, so that's what 1/3 does. So what would it be a ramp for 3? Or 3 would be go over 1 and then up 3. So it would look more like this, right? 2/5 would be, if this is 5, so up should be a little less than halfway, because halfway would be 2.5. So that would be a ramp for 2/5. Now, what would be the ramp for -2/5? Remember, these were all jump ramps, right? We're going that way. But for right this, the run is still 5, but the rise is going to be over on this side because we're going down 2. We're going down 2 and over 5, like that. And try to make yours look as much like right triangles as possible, right? That's for a line going that way. All right, so yesterday we learned we can just look at that, and we know the slope is 3, and we know the y-intercept, which is very different than the y. That over there is the y-coordinate, not the y-intercept. The y-intercept is that, well, that's b, which is the not 0 part of the y-intercept. So the y-intercept is 0, -7. Over here, the slope is -2/5, and the y-intercept, and I'm a little sloppy, is 0, 3. All right, so we're going to be plotting linear functions using those ramps you just drew. Right, we learned how to plot linear functions, right? So say this is this is y equals, I believe, 1/2 x plus 5, right? And you'll learn, I just looked at that and knew what function it was. You'll be able to do that in a little bit. But, oops, I got 2 equal signs there. But, so I don't need this twice. But, right, we learned you could put 0 in there and do 1/2 times 0 plus 5 is 5, and 1/2 times 2 plus 5 is 6, and 1/2 of 4 is 2, and 2 plus 5 is 7, and so on, and then plot the points. Right? We did that. And that's the slow way. Now we're going to learn the fast way. And you're going to be plotting hundreds of these. So you really want to know the fast way rather than the slow way. You know, you ever get confused? Yeah, you can do it this way. Plot points and draw a line through them. Okay, so this is what we're going to do. So we're going to plot our first linear function, y equals 3x minus 7. Again, if you don't have a printer, you're going to make a little sketch like that. Okay, and so the y-intercept, that's where you start. So what is it? 0, -7. So everyone find 0, -7. So it's down here, right? If you have a sketch, you're going like that. Now, slope of 3. Think about what you just did in the warm-up. Slope of 3 is over 1 up 3, right? Over 1 up 3. So from where we started, I want you to go over 1 square and up 3. Over 1 and up 1, 2, 3. Right? Make a new point. That's another point on our line. Let's do it again. Go over 1 and up 3. Over 1 and up 3. Keep doing that. And you get all the good intersections along here. Once you feel like you have enough, you're going to need a straight edge today, so pause if you don't have one and go get it. And you're going to take your straight edge and you're going to draw a line through your points, and you just graphed this linear function y equals 3x minus 7 way faster than if you had to sit there, make a t-table, think of some points, right? Think of some points, and then start evaluating. Could you do it that way? Yeah. There's 0, whoops, it's not 0, -4, it's 0, -7. 1 goes with -4, right? You could do it that way. Notice I'm getting the exact same points. 2 goes with -1, and 3 goes with 2. You're getting the exact same points, but you're doing it faster. All right, so that's what we're doing today. I've taught you the lesson. We're going to practice it a whole bunch. All right, so start at the y-intercept. So 0, 4. What's the slope? Now the slope is 1/3. Before you start going, think about 1/3. Look at the warm-up. Right? It's over 3 and up 1. So you're going over 3 and up 1. Very different than 3, right? Slope of 1/3 is over 3, up 1. Now, there are definitely times, and this could be one of them, where you're going to have to go backwards, right? But now you see the pattern, right? Once you see the pattern, it's easy to go backwards, I think, right? They've all got to come out in a straight line. And remember, you're going to draw a nice long line. So when you draw your nice long line, right, you want a lot of points. And so there is our linear function. If I missed, all right, I'll do it again. That's why you use pencil in class. Everyone, including Mr. Ben, makes mistakes. There you go. Better. Okay. And you plot the linear function y equals 1/3 x plus 4. Oh, by the way, every once in a while I get people who start writing linear functions and forgetting about the y. That's not a linear, that's an expression. Linear functions always have an x, an input, and a y, an output. And so there we've graphed it. All right, try this one. So y-intercept is 0, 3. All right, so we're going over 5 up 2. Right, over 5 up 2, over 5 up 2. So let's go backwards down to over 5. You'll know if you've done it right if they come out in a straight line. And for those who are doing sketches, all right, this is the way you do the sketches. Here's the good news, okay? You don't need a whole big grid. Right? You go 1, 2, 3, 0, 3, and then you go 1, 2, 3, 4, 5, and then up 2. And although yours is not as accurate as the ones with the grid, for sure, you still have the concept of what the line looks like. All right, so now compare these two. They're very similar. So we're starting at 0, 3. Now, the slope here is -2/5, right? The negative goes with the rise, always. The run is always a positive number. So that's what this looks like. We're going down 2 and over 5. Down 2 and over 5. I have a construction worker in the background right now. If you hear some water running, that is them. It is not me. But this is y equals -2/5 x plus 3. Okay. Now, I take the grid away for everyone, including people, so the people who didn't have the printout, well, they're already ahead of the game. They've already done this. But now the grid is gone. You do it the same way. Right? You find the y-intercept, 0, -4. And you go, this is the slope of -3. So the rise is the -3 part, going down 3 and over 1. So we go down to -7 over 1. All right, down to -10, right, and over 1. Now you definitely want to go backwards here. So we're going to go over 1 and up 3. Over 1 and up 3, right? And right, if you're sloppy, they don't come out in a straight line. I was a little sloppy with this last one. Right? Good news is there's a thing called, that's horrible. Let's fix it. I used the wrong side of my ruler. Better. Okay. All right, so what are the domain and range? What are the possible values of x and y? Right? X, this goes on forever. It may take a long time to get over to a positive million and negative million, but the domain is all real numbers, right? for linear functions, this is almost always the case. We're going to have other kinds of functions where this is not the case later in the year. And the range, it goes up on forever up there, on forever up there. The range is also all real numbers. Okay, so plot that. We're really just practicing. Y-intercept is 0, 5. Slope is 1, right? That's the easiest one to plot because you go over 1 and up 1. Right? And you can go backwards very easily there. Right? Every intersection is good. And there's our linear function. All right, so y equals -4. Now, I want you to be careful on this one. This is y equals 0x minus 4. There's a big hint. So plot this. Right, the y-intercept is 0, -4. What's the slope? 0. And we know that because there's no x. That's the only way x goes away. All right, so what kind of line has a slope of 0? A horizontal line. All right, so this is the graph of y equals -4. It's a horizontal line. It's a line parallel, we're going to learn that word if you haven't already, to the x-axis. Okay, and what that's all about is that every point on every y coordinate on there is -4. And the x coordinate doesn't matter. That's why it's not even in the equation. It's gone because the slope was 0. All right, number 9, we're practicing. Y-intercept 0, 1, slope -5, down 5 over 1. And go backwards and go up 5. And draw a line. Way faster than t-tables. All right. What are the domain and range? All right, I killed this, and the reason I'm killing it is because it's a standard that you know what domain and range is in different kinds of functions. In linear functions, it's all real numbers for both most of the time, right? And the sketching people, you're actually getting good. So whenever you're lost this year, you can draw yourself a little sketch, especially people who've had to do this all the time. You're going to get really good at this, right? Oh, yeah, that's what y equals -5x plus 1 equals. And you should label the x and y axis. Y-intercept is 0, 5. Slope is 1/2, right? So that's the run. So the run is 2. The rise is 1. So over 2, 1. You know, people go too fast and then they do the slope of 2. Right? A slope of 2 is very different than a slope of 1/2. All right, and we can do some backwards ones. I've been doing this a long time, so I can go really fast. Okay, as long as I don't get too sloppy. And we're always putting arrows on the end because showing these go on forever. Number 11, 0, 7. What's this slope? -1, right? So this is down 1 over 1. Every intersection is good. And there it is. Y-intercept is 0, -3. The slope is 1, so we're going over 1 and up 1. Done. Good luck with the homework.